Hello students, our topic is geometric progression. A sequence of terms to is a GP. How? Each term we can get, after the first term, we can get multiplying one constant term. How? The first term of the GP is 2. Suppose it is A. And the second term is 2 into 3. Third term 6 into 3. Fourth term, third term into 3. A sequence of terms, suppose it is 2, 6, 18, 54 is a GP. Now how? That to discuss. Here the first term is 2, A is 2, and the second term 6, we can get the first term into 3. Third term 18, it is the second term into 3. Fourth term 54, it is the third term into 3. What is the first term? It is 2 into 3. Second term 6 into 3. So it is 6, it is 18, and third term is 18, it is 54. So it is a GP. The first term into a common term, the constant term with each term, we can get a GP. So each term is multiplied after the first term is multiplied with a constant term. That constant term, if we denote it by R, this R is called common ratio. So in a GP, the first term is A and the constant term which is multiplied with each term to get the succeeding term, it is called common ratio. Now we are to find out the general form of a GP. What is the general form of a GP? It is A, first term A, the common term, common ratio, if it is multiplied with A, it is AR. Again, AR into R, AR square, AR cube, like this. So I think it is very much clear to you how the general form we can have, that is A, AR, AR square, AR cube, and so on. And next, we have to find out the general term of a GP, or we can say the nth term. So what is the nth term of a GP? It is the first term, it is the common ratio R. So second term is AR, second term is AR, that we can write AR to the power 2 minus 1. Third term, which is AR square, we can write it is 3 minus 1, and the fourth term, which is AR cube, that is So it's very simple to find out or to tell the nth term, which is a r to the power n minus 1. If the second term is a r to the power 2 minus 1, third term is a r to the power 3 minus 1, fourth term is a r to the power 4 minus 1, then simply the nth term is a into r to the power n minus 1. So it is very important. The nth term of a GP is a into r to the power n minus 1, and we get denoted by Tn. So Tn is a into r to the power n minus 1. Now you can find out if I give one example. Example 1, suppose it is 2, 6, the same example, 2, 6, 18, 54, and my question is that to find out the fifth term, that is T5. Can you find it? What? Simply A is the first term is 2 and common ratio R. How we can get the common ratio? Dividing the second term by first term, third term by second term, fourth term by third term. So dividing it, it will be 3. So common ratio is 3, R is equal to 3, A is 2. Now put here T5. T5 is what? 2 into R, R means 3. N minus 1, N here it is 5, so it is 2 into 3 to the power 4. This is the answer. Let us discuss one problem in GP. Here it is given the third and seventh term of a GP are 4 and 64 respectively. Find out the GP. So the third term is given, it is 4, and the seventh term is given, it is 64. So T3 is 4. T7 is 64, it is given. We have to find out the GP. So let us suppose the first term is A and the common ratio is R. So we know the nth term TA of a GP is what? A r to the power n minus 1. So T3 A r to the power 3 minus 1, that is a r square. What is that? 4. T7 A r to the power 7 minus 1, that is a r to the power 6 is what? 64. So if it is equation 1, if it is equation 2, solving equation 1 and 2, we can get the value of R and A. So simply dividing 2 by 1, see here we can get a r to the power 6, the left hand side a r square, and the right hand side 64 by 4. A cancel. It is r to the power 6 by r square, that is r to the power 4, and it is 16. Now r to the power 4 is 16. So r to the power 4 is 16. We can write it is 2 to the power 4. And here r is equal to plus minus 2. Because minus 2 to the power 4 is all 16, and r to the power 4 is positive r to plus r2 to the power 4 is also 16. So r is equal to plus minus 2. Now putting that value of r, we can get the GP. Now what is the general form of GP? General form of GP we know AR square, AR cube. Is that? So what is the first term? First term we have to find out A. So when R is 2, we have to find out the first term. When R is 2, it is the case 1. When R is 2, what is A? Put any one equation, it was T3, that is AR square is equal to 4. So when R is equal to 2, it is, so A is 1, and case 2, when R is equal to minus 2, AR square is equal to 4, that is minus 2 whole square is equal to 4, that is, it is again 4, so A is 1. So the value of A is 1 and the value of R is plus minus 2. Value of A is 1 plus minus 2. Then we have to find out the GP. What was our question? Find out the GP. So find out the GP. We have to find out the GP. Case 1, when R is equal to 2, the GP is A 1, AR 1 into 2, AR square 1 into 2 square, AR cube 1 into 2 cube, and so on, which is 1, 2, 4, 8, and so on. And when R is minus 2, the GP is A 1, AR 1 into minus 2, AR square 1 into minus 2 whole square, AR cube 1 into minus 2 whole cube, and so on. So the GP is 1, minus 2, 4, minus 8, and so on. So the GP is when R is equal to 2 is that, when R is equal to minus 2 is that. We have discussed earlier the general term which is nth term of GP. Now we are to find out the sum of first n term of the GP. Here two formulas are there depending on the value of R. Sn, the sum of first n term of the GP is A into, A is first term you know, and R is the common ratio. So A into 1 minus R to the power n by 1 minus R when R lies between minus 1 to 1. So depending upon the range of R or the value of R, we have to select the formula whether Sn is that or Sn is that, A into R to the power n minus 1 by R minus 1. So when we will apply this formula, when R, the value of R is greater than 1, or the value of R is less than minus 1, and when R, the value of R lies between minus 1 to 1, then we will apply this formula. Let us try one example. 3 minus 9 plus 27 up to 8 terms. What is our question? Question is find out the sum. Find out the sum of that GP up to 8 terms. Clearly the first term is 3. Now we have to find out the common ratio, which is R. How to find out the common ratio? Dividing the first term from the second term. So minus 9 by 3, which is minus 3. And for each two terms, dividing each two terms, we can get the common ratios and constant. 27 minus 9, what is minus 81 by 27. So the common ratio R is minus 3. Now you have to find out S8, the sum S8, 8 terms, up to 8 terms. Now two formulas are there. Which formula we have to select or we have to apply? Here R is minus 3. I have told you, depending upon the value of R, we will select the formula. Here R is minus 3, which is less than minus 1. You know it, that R is minus 3, which is less than minus 1. So r less than minus 1, then we will apply this formula. So S8 is what? A into r to the power n minus 1 by r minus 1, which is A. The value of A is 3. R, common ratio R, minus 3. N is 8 minus 1 by minus 3 minus 1. So it is what? 3 into minus 3 to the power 8, it will be positive. So 3 to the power 8 minus 1 by minus 3 minus 1, which is minus 4. You have to calculate this and simplify. Simplifying this using a calculator, you can find out the answer. How to apply the summation, the sum formula. So here one another problem is for you to solve the sum of that GP to n terms. Acha, if it is given, this progression is given, how to check whether it is in AP or GP? You know how to check. If you have to check it AP, so second term minus first term, third term minus second term. If one constant is coming, then it is in AP. And whether to check it is GP, the succeeding term dividing by the preceding term. If it will come one constant, then it will in GP. So the first term is 1, clearly it is 1, and find out the common ratio or common difference, then apply the formula. Depending upon the value of R, you know which formula you have to apply. So it is for you to solve, and try it, solve it, and write it in the comment box. And the next problem is I will solve for you, that is if A, B, C are in GP and that condition is given what? A to the power 1 by x is equal to B to the power 1 by y is equal to C to the power 1 by z, then show that x, y, z are in AP. That is most interesting and most important problem. So let us start. A, B, C are in GP with that. Okay. A, B, C are in GP. That means what? That means if we divide the second term by first term, B by A, obviously it will be equal to C by B, because it is in GP, that is given. So from here we can get B square is equal to AC. That is given. Second condition, A to the power 1 by x is equal to B to the power 1 by y is equal to C to the power 1 by z. So it is given A to the power 1 by x is equal to B to the power 1 by y. So all are equal, so equal to a constant we can. So A is k to the power x, we can write, B is k to the power y, and C is k to the power z, you know. Now, if it is a equation 1 and this value of A, B, C we put in equation 1, so let's see what we will get from equation 1. B square is equal to AC. So what is the value of B? B is k to the power y. So B square is equal to A into C. What is the value of A? K to the power x. What is the value of C? K to the power z. So from the laws of indices we know it is k to the power 2y is equal to k to the power x plus z. So the bases are same. So we can say 2y, the power 2y is equal to x plus z. So up to that is, I think it is very much clear to you. Now what is our question? Focus on that. Show that x, y, z are in AP. So if 3 terms are in AP, to show that 3 terms are in AP, what you have to show? In rough, just wait, the second term minus first term is equal to the third term minus second term. You have to show that. If we can show that this, so these are in AP, we can show. Now from this we have to show. Can we write from here y minus x is equal to z minus y? Yes, we can write, because see, this y plus y, if we simplify, so it will be 2y, and x, if we take it on the right side, it will be x plus z, which is that. Clear? So we can say x, y, z are in